All right, friends and students, today we are building a simple DIY power supply for electronic projects, right? So what is the importance and what is the power supply is important for you? Why? Because it has a variable regulated power supply. That is, you can vary the power supply. That is, there is a button, or rather there is a control from 0 to 22 volts positive supply with fixed minus 5 volt regulated output. Please remember 22 0 to 22 volt positive supply, that is also regulated, and you will get minus supply of 5 volt, that is also regulated output. Okay, so these type of projects will be helping you because you are getting positive voltage. You can select and you can fix it up to 22 volts and negative voltage of 5 volt also if it is required for your project. 5 volts sometimes you will be requiring it for some of the circuits like display circuits and all. That's why this project is important. Okay, so I will just go to the next slide and I will just try to show it to you. Okay, so we have come to the next slide. What are the components required? The list of components. So we have used one regulator LM317. We have used a regulator, one more regulator, that is negative voltage regulator 7905. We have used a variable resistor of 10 kilo ohms, one, right? Diodes, IN 4007, they are the rectified diodes, simple, very common diodes, 6 numbers, and fixed value resistor, 4 numbers or 3 numbers, we have used it. Capacitors, 5 numbers, we have used it. 0.012 capacitor, 1000 microfarad 2 capacitor, and 220 and 470 microfarads capacitor. That is a filter capacitor. And one LED. These are the simple components what we have used. Okay, now we'll see this diagram. You can see here, I have made this diagram on KiCad software. So this is the diagram. I will be sharing this complete portion with you. Okay, so I will just show you once again. I will just a moment, please. I will show you the KiCad diagram. All right, students, now you can see the same diagram. I made it on KiCad software. It's an open source software. When the time comes, I mean, in the coming future, I will tell you how to use this software, how to make schematic drawings, and how you will convert it to PCB also. Okay, so simple first step down transformers, 0 to 26 volt AC. I've used a bridge rectifier. 4 diodes are there in a bridge rectifier. After there, converting to DC, I have the same power supply, that is same power line. I have given it to the two inputs of the regulator, 12317 regulator, that is variable regulator, and 1 to fixed, that is 7905. Okay, the supply has been given to pin, but please remember different pins. One is pin number 3 and one is pin number 2. Okay, it's a, then I have connected a 1000 microfarad capacitor and 0.01 microfarad capacitor on the same positive line, that is the input line. Okay, pin number 3 I have taken as the output, that is minus 5 volt. You can see I have connected one LED just for indication purpose, and 2 capacitors are there, that is one is 220 microfarad and one again is 0.01 microfarad. From this output, please remember there is no common output. There is a separate output for negative supply. Okay, so one I have indicated in this thing, that is one is minus and another is minus 5 volt DC. You come down to the 317 output. So I've used one variable resistor so that you can vary the voltage, that is the positive voltage, from 0 to 22 volts. Okay, so this is the simple circuit. You will find it, and the output I have used 1470 microfarad capacitor for filtering, and you will get 0 to 22 volts output DC. The negative, again I am telling you, the negative is separate for this and positive is separate, whereas the minus voltage will have negative and the separate negative and positive voltage. Okay, we will discuss about KiCad and other about this software in the coming future. Okay, let's go to our lab and just complete this circuit and see the output. All right, friends and students, we have come to the lab. As we have seen in the circuit diagram, I have made the power supply, I have given the connection. First of all, we will measure the things. I will explain you one by one. First of all, I have used a power supply, a transformer here. You can see here. I'm putting my, I'm putting my screwdriver on this. So what is the voltage output from the transformer? So there are 2 points connected, this two black wires. We'll just check the voltages. For that, what we have to do, we have to put it on AC, 200 volts range. Okay, it's a step down transformer. So we'll just check what is the voltage coming on what is the AC voltage coming on this. So I will just put it on this and we'll just check. 1 second, please. So we are checking the voltage. So it is 18.8 volts. You can see 18.8 volt AC. Okay, right. So we are getting 18.8 volts. I have used a bridge rectifier here. Okay, so let's see what is the output from the bridge rectifier. I'll put it on 200 volt DC. This is the negative of the bridge and this is the positive of the bridge. So I will just check what is the supply voltage. So approximately it is coming to around 24 volts. Got it? 24 volt. That is DC is 24 volts. AC was approximately 18 point some change it was. Okay, DC output. Now what is this actually circuit? This regulator, this regulator is LM317, and this regulator, the behind regulator to which I have connected a LED, this is your 7905 negative output voltage regulator of 5 volt. It will give you 5 volt. So please remember here we have taken 2 grounds. Okay, 2 grounds. So one is the ground, this is the positive. If you want to take the voltage in positive voltage, then this is the ground, and you have to, sorry, this is the output and this will be the ground. This black color wire here, you can see this wire is ground and this is output voltage. Whereas if you want that negative voltage, 5 volt negative is to be taken, then this will be the negative voltage. At the time the ground will be here. So we have 2 grounds, one this and one this. This is for negative, this is for positive, and the output, this is regulated output, variable. That means we can vary it from 1.5, 5, 6 up to whatever, because that output we just now we have checked, it is 24 volts. So approximately we can go up to 18 volts. Okay, and this is the another one that is fixed. This is the fixed one. This is -5. So first we will go for minus voltage. So for checking the minus voltage, where we have to put it, I said 5 volts, no? So I have to put it on 20. Okay, so what I will do, you just check here. I'm taking the negative. This is, I'm putting it on the negative point and I'm testing. This is the output. Okay, how much it is coming? 4.99, approximately 5 volts. Okay, 4.99. So I will just take, because I have connected black now, so it was coming in positive. So what I will do is I will connect this one and I will check. So minus 4.99 volts. Got it? Minus 4.99 volts. Now we have got negative voltage. Same power supply, only regulator minus. The bridge is same. The connections are same. Filters, I will tell you what are the different filters we have used it. So this, okay. Now we will we will check the regulated voltage. So what I will do is, this is positive voltage. I said no, this is positive of the regulator and this is the negative one. So what I will do is I have directly connected positive to it and negative I am connecting it to this point. So you can see it is approximately positive. How much volt? 12.74 volt is coming. Now what I will do is, this is a preset over here. Preset means variable resistor. I am just moving that variable resistor. See, the voltage is increasing, right? Okay. It is going up to 14 volts approximately. And I'm just reversing it. Let's put it to 6 volt. 9, 8, 7, I'll put it to 6 volt, try to put it to 6 volt. Okay, so this is 6 volt. So positive and negative for regulated power supply, that is variable regulated power supply. And recently we have taken the negative from here. At that time this was the ground. So I will just show you the components. This LED I have connected to 5 volts. Okay, this filter is for this regulator, and this filter is for this regulator. It will be reverse positive and negative. Please remember, this is potentiometer, that is variable resistor, you can see in the middle. Okay, I will share the circuit with this. So why we have made this circuit? What is the point in making this circuit? Why? Because some of the circuit will use negative as well as positive power supply. So how from single bridge, from one bridge, how can I take positive output regulated? Please remember, regulated as well as negative voltage regulated. Okay, negative is also regulated because it is coming from this IC. Positive, as we can vary, we can fix it and we can vary it. It comes from this IC. I hope you understood this particular circuit.